We're on to the very last problems of this benchmark, guys. We're on the home stretch. It's a long benchmark, but there's a lot of it you can do in the calculator and check in the calculator. Okay? Number 39 says a ball is thrown into the air from a height of 4 feet at the time of t equals 0. That's someone throwing a ball, okay? So maybe it's a kid throwing it overhand, maybe it's an adult throwing it underhand. They're releasing it, and the release point is 4 feet high in the air. Think about just someone throwing a ball. It doesn't start on the ground. It starts up in the air when it leaves their hand. It's already high, okay? And then they give you the function equation. So earlier in the test, they asked you for that. Here they're giving you one. You could compare that to that previous problem and kind of check your work from that one if you wanted to. T is measured in seconds. H is the height in feet. What value of t? So what value of time best describes when the ball is flying through the air? Okay. So this is asking you about the real world problem. And with time, it should always, but it will most likely, especially in the scope of this class, start at 0. If I was going to throw a ball in the air and time it, how long it's in the air, right once it leaves my hand, I click the stopwatch. That starts the time at 0. That gets rid of A. A would be the domain of the entire parabola, but we want to know about this just the real ball. And there's no negative seconds in the real world, or we just don't use them. And so we have to start our time at 0. You'll see the other 3 options all have a time starting at 0. What we want to know is we toss that ball and we start our stopwatch, and we want to know when did it hit the ground. Well, when we go to graph this, when it hits the ground is just that second 0. You can see the flight of the ball and its height change in the air, and when it hits the ground is that second 0. It actually kind of looks like a ball being thrown through the air if you zoom out and look at the parabola and get it nice and spaced out. But for the scope of this problem, when we hit zoom 6, we see here's our parabola taking off, there's our ball taking off. And you can see that that's it hitting the ground. That's the height of our ball, represented by the parabola, reaching 0. Right there where it hits the ground that second time, or that first time when it hits the ground. Leaves the hand right here, goes up, hits the ground right here. Okay, gains height, gains height, gains height. Reaches its maximum, loses height, loses height, loses height, hits the ground. So we want to know what's the value of t there. T is our x-axis. So we want to know what the x value of that point or that 0 is. We go to calculate the 0. We want to be to the left of it. Let's get a little bit closer. Left of it, in this case, means left and above. We hit enter. That's the top piece of bread. Now we need the bottom piece of bread. Sandwich it in. Okay? 2.656605. Looks like they rounded to 2 decimal places. So if I'm looking at the second decimal place, I look at the number behind it. That's going to bump it up. So 2.66, comma 0 is that other 0. And that's what we wanted to know. When did it hit the ground? It left our hand at 0 seconds whenever we released the ball, as it says in the problem right here. And it lands on the ground after 2.66 seconds, which is option C. Where can you go wrong? Well, if you're just entering in and looking at maximum heights and things like that, you might get stuck with that one, forgetting we're talking about x values. Time is on the x-axis. Okay, 0 4 is just for someone who looks and goes, oh yeah, it gets 4 feet or it starts 4 feet off the ground. They're just picking answers. Okay, just throw that in the calculator and calculate the 0. For the next problem, we're dealing with the same ball. Okay, and it's saying here's our ball getting tossed through the air, and it wants to know when will the ball reach 25 feet. It doesn't say that that's our maximum or our minimum or anything like that. We want to know when's it going to reach 25 feet. So if I zoom out to see this whole parabola, it gets a little bit messy. Okay, you can barely see it. If I want to know when does it equal 25, I graph the line y equals 25. Here comes our y equals 25 line. There's our parabola. We're going to have to zoom out again. I forgot about that. My bad. I shouldn't have hit zoom 6. Should have just hit graph. So here comes our hard to see parabola. But then here comes our line of 25. Everywhere that parabola touches it is going to be where the height of 25 of the ball was. Okay? I can't quite see it, so I want to zoom in on that one specific piece. You could also zoom box this, but you can see I'm moving my cursor up over there to that spot that I want to zoom in on, and I press enter. Okay? So there's my parabola. Here comes that line of 25 feet. So you can see our ball actually was 25 feet high twice. And that kind of makes sense. If you throw a ball up in the air and you say, hey, when's it 10 feet off the ground? Well, if I throw it 30 feet up in the air, when I first release it, it gets to 10 feet pretty quickly, goes way all the way up, hits a maximum, comes all the way back down, and on the way back down, it hits that height too. Same thing with 25 feet. Our ball was thrown up in the air. Right here, it's 25 feet high, but it's going to keep climbing. It's not like it hit a ceiling. It kept going up in the air. Reached its maximum, comes back down, and here it hits 25 feet again on the way down. So we should have two answers. That eliminates D. By just thinking about it and thinking it through, you can eliminate answer A because at 0 seconds, we know that our height is at 4 feet, but we'll just amuse ourselves and we'll find out where these two things are. Well, to find the first one, you can go second, calculate, and we're looking for 5, an intersection. Okay? It says, hey, where's the first curve? It's right. We're on the first curve. We're on our parabola. Hey, where's the second curve? Right there. We hit enter, enter. So really, you just press enter, 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 and it tells us the first time it reaches, time is x, it reaches 25 feet is 7 point, and we're going to 2 decimal places, so 7.1 seconds. Or 0.71 seconds, my apologies. 0.71. Well, that kind of goes ahead and tells us it's going to be B. Okay? That just kind of lets us know, oh, it's got to be B. That's the only one that's got that in there. Now, you would also, if there were 2 of them, you would just check the second point. Okay? Check it for the intersection. But really quickly, before we're done with this, I want to run through another way to do this problem that Coach Setzer brought up at the end. And it's if you're really not good at that calculator, what they're doing is they're telling you what the height is. They're telling you what h of t is. So you could have 25 equals negative 16 t squared plus 41t plus 4. Okay? Well, that's not in standard form. To be in standard form, I'd subtract 25, subtract 25. I get that 0 equals negative 16t squared plus 41t minus 21. And you say, well, Mr. O, what good did all that do? Well, it's going to take a little bit of work and a little bit of hard extra work, but the good that did is now with this new formula, because we have a 0 on one side, if you want to, guys, you can quadratic formula this thing. And it's going to get pretty ugly and messy, but you're looking for decimals. So we don't mind it getting ugly and messy because decimals are pretty easy to work with. Negative 41 plus or minus square root 41 squared minus 4 times negative 16 times negative 21. Okay? When we go to put all this in the over 2a. Ooh, about to forget that. Over 2a. And when we go to put all this in the calculator, let's start with the minus 1 first. Negative 41 minus, actually I should probably do parentheses, negative 41 minus square root of 41 squared minus 4 times negative 16 times negative 21. Count up some parentheses. That'll end my square root. That'll end my numerator. I'll divide by negative 32. Oh, what did I mess up? Messed something up. Probably misbalanced my parentheses. Let's see. Oh, no, I see my error right here. And unfortunately, I can't go back and grab mine, okay? But simple calculator error, typed it in wrong. Minus. If this is confusing you, like it just, like me messing up on this and all that, just ignore what I did. Just graph them and find the intersections. I kind of just want to show a few people the exercise here that's kind of working out. 41 squared minus 4 times negative 16. Let's make sure to type that in right. Negative 21. That's my 21. That's my radical closed. That's my numerator closed. Divide by negative 32. And we get 1.85. Okay? We get our 1.85. And that's what we want for this second. Whoops. And that's what we wanted for